Contrary to popular belief, starting your home electronics lab doesn't have to break the bank. While it's true that you could spend tens of thousands on specialized, high-precision equipment, it's more accessible today than ever to fully outfit your first lab for under $1,000. In many cases, a lot lower than $1,000. I'm going to show you how to do it, what to buy in what order if your budget is especially tight, and the common pitfalls which you should avoid. Towards the end, we'll discuss some non-essential items which you can prioritize and add to your lab based on your needs. And remember, just because something is non-essential for starting your lab doesn't mean it won't be essential for certain projects in the future. There are 5 levels to building out your lab, and it's important to keep them in the right order. I mean, you wouldn't buy an oscilloscope without a table to set it on now, would you? So the first level is your workspace. If you're building out a lab, you're no longer hijacking the dining room table, but looking to put together a space specifically for electronics work. The 3 things an effective workspace has is lots of bench space, lots of organized storage, and lots of light. A desk or bench can be quite an expensive item and eat a lot into your budget before you even buy your first piece of electronic equipment. You may already have a desk, but if you don't, buying used in your local area is going to get the biggest bang for your buck. You know what will fit your space and preferences, but you should maximize the desk surface you get. The most common pitfall here is getting a desk that is too shallow. If you can swing it, go for a workbench that is 3 feet deep or deeper. This will allow you to set up your lab instruments at the back of the bench while still having lots of workspace at the front. If you can't go that deep, it's alright. Mine is not as deep as I would like, and I compensate by putting my oscilloscope and power supply off to the side, tilted at an angle. Whatever you do, don't get a shallow desk. And there's always the build-it-yourself route as well, if you enjoy woodworking, but that's up to you. Along with your desk, you need space to store your tools and components. I highly recommend these little plastic drawer chests for small parts. I have 3 of them, and they're terrific for sorting my component stock and making them all visible and accessible. They can be a little pricey, but you can start with 1 and add more as you fill your lab. For larger items, tools, and assorted component kits, you can buy shelving or cabinets, freestanding or wall-mounted. For the freestanding variety, once again, buying used in your local area will get you some great deals. The more storage you can fit in your space, the better. You don't want piles of boxes filled with unsorted parts or the residue of the last 10 projects cluttering your desk. You want a workspace that is easy to keep clean and organized and makes it a joy to work in rather than a burden. The last major component of an effective workspace is lighting. Not the overhead lighting on your ceiling, but direct lighting for your desktop. Mine behind me is a custom fixture that I made using an LED strip and some aluminum angle bar, and it works well. But for simplicity's sake, I recommend getting at least 1 articulating desk lamp. These are available for cheap online, and you can move them to place the light source wherever you want over your desk. Ultimately, it's up to you, but the criteria you should be looking for are that it's bright, lights your workspace adequately, and you don't cast a shadow over your work. There are few things more frustrating than trying to light your work only to have the shadow of your head cast onto it. And that's it for level 1. Workbench, organized storage, and lighting. The next level of building your lab is acquiring basic tools. This is a quick one since they're all inexpensive, brand new, and can be bought online. Of course, a multimeter is the most basic instrument you'll need, and since you've already decided to build out a whole dedicated electronics lab, you've probably already got one. But if you don't, a $20 meter on Amazon will do the job just fine. You can get that fluke later on down the road. Next, you'll need a precision screwdriver set. Mine is an iFixit branded set, but you can get much cheaper sets around $10 if your budget is tight. From there, you'll need some flush cutters, wire strippers, and some pliers. Consider a set of tweezers for handling tiny parts or hot parts while soldering. And don't forget helping hands. I have this type with a heavy metal base and 4 gooseneck arms with alligator clips on the ends, which I recommend. It serves me well. Just be aware that the gooseneck articulation doesn't hold its position well if you're near the limit of its bend radius. It wants to unbend. And that's it for a lean level 2. Multimeter, screwdrivers, cutters, strippers, pliers, and helping hands. 3 levels to go. On level 3, we're ready to start thinking about the actual electronics, the reason you're building the lab in the first place. Specifically, your component stock. You may already have some stock, but there are some things in particular which you'll want to have handy all the time. And you can get these in kits of assorted parts if you aren't yet sure what to pick out from a supplier. These are resistor kits, capacitor kits, diode kits, potentiometers, and transistors. If you want a more comprehensive list with specific recommendations, watch my video titled "What You Need to Begin Electronics." This is just a starting point, and you can add whatever you want according to the types of projects you want to build. In addition to these, get some breadboards and solid core hookup wire to make your own jumpers. And don't cheap out on the breadboards. The cheap ones are usually too loose, too tight, or a combination of both. I use Busboard brand breadboards, and they're perfect. They cost about $10 per 830 point breadboard. Get as many as you think reasonable, but start with at least 3. You really can't have too many. And on level 4 is where we start bringing in the heavy weights. If you watched my video titled "The 3 Most Essential Electronics Lab Instruments," you already know what's coming. These are going to be your lab bench workhorses. The most important of which is the oscilloscope. If you're dealing with analog signals, this is indispensable. It's your window into what your circuits are actually doing. It's also going to help you develop and debug the physical layer of digital circuits, since digital is basically just quantized analog. Or not basically, it is quantized analog. Seeing what's happening with the signals can show you where digital errors are coming from. This is going to be the most expensive piece of equipment you need to begin your lab. Well, that is if you buy new. The pitfall you need to avoid is buying one of those cheap bargain units, which are usually handheld. To be clear, they work well for what they are, but they are very low bandwidth. You aren't getting far outside the audio spectrum with them. I recommend budgeting $300 for a new digital oscilloscope, which you can buy on Amazon. Handtech and Regal are the 2 most popular entry-level brands, and both have offerings in the $200 to $300 range. If you must go cheap, look on eBay for used analog oscilloscopes. You'll find some old Tektronix units for a few $100s, but more importantly, you'll find some lesser-known brands for less than $100. If you're keen and patient for a good deal, you can find a basic 20 MHz scope close to $50. It won't have all the fancy features of the $250 digital scope, but it will serve its purpose of visualizing what your circuits are doing inside. After the oscilloscope, you need a bench power supply. I recommend budgeting $100 for a decent linear power supply. These are less noisy when operating near their limits. But if you plan on staying well below their limits, you can get a decent switching power supply for about $50. The difference between the two is that the linear power supply works by continuously varying its resistance to maintain a constant output voltage. It just wastes the rest of the power as heat. That's the price paid for a smooth output. The switching unit switches very fast between full on and full off at a varied rate based on the load to maintain a consistent output voltage. These are very energy efficient, but sacrifice noise performance. What you want to look for in a power supply is variable voltage, variable current limit, and output display. Some will show you output watts, and others just the voltage and current. Both are okay. The watt display is mostly just for convenience, whereas the voltage and current displays I would consider essential. The last piece of equipment in level 4 is a soldering station. This is what you will use to turn your breadboard prototypes into permanent builds, to make repairs, to iterate on your builds, and to salvage good parts from junk. I don't recommend those all-in-one soldering irons for your lab. They're great to get started on because they offer you zero luxuries to lean on as a beginner, but they aren't good as a permanent fixture for your bench. You want something temperature adjustable and interchangeable tip. Ideally, you'll have an accurate temperature readout on a display rather than just a scale printed around a knob. This way, you know exactly the temperature that your iron is set to, and you know exactly what temperature it is. I recommend a soldering station where the iron is separate from the power source and temperature setting. So just like your typical soldering station where you have the unit and then you have the iron that's wired into it. Mine is a $50 Yiwa brand 939D+, which comes with an iron stand and brass wool tip cleaner. This soldering station serves me very well, and I have a review video about it on my channel if you're interested in it. So level 4 is oscilloscope, power supply, and soldering station. The last level is more specialized equipment. This is the stuff that is non-essential now, but could become essential later on. I consider a function generator to be very important for analog circuit design. The only reason I don't consider it essential to begin your lab is because it's a simple beginner project to build a square wave and triangle wave generator. I have a video about just that on this channel. But you can buy capable units on the low end for under $150 if you'd rather just buy one and focus on other projects. When you begin working with SMD components, a hot air rework station will make an excellent companion to your soldering station. Not a heat gun, but an adjustable temperature, adjustable airflow rework station. Some people recommend the types where the air is heated in the station and piped to the wand, but in my experience, the type with the heater in the wand is fine. Also much less expensive. I'd avoid an all-in-one unit and get the kind that has a station separate from the wand. In the vein of soldering equipment, a desoldering gun is extremely useful if you do a lot of salvaging or repairs and replacements of through-hole components. If you can swing a Hako desoldering station, it's worth it. But the cheaper Yiwa that I have works fine too. Just be sure to keep up on the maintenance, as they can get quite gummed up inside if you suck up too much flux. You really want to keep that vacuum pump in good shape or it will stop working. And then of course there's the other desoldering equipment like desoldering wick, manual handheld desoldering pump that you prime a spring and then it pops back. All that usual stuff, but those are some cheaper items that I'm not really spotlighting at the moment. A small digital microscope can be a lifesaver when you're doing tiny, delicate work. From repairs to soldering inspection and PCB mods, there are things you just can't do reliably if you don't have a microscope to see it. You can get a little one for around $40 or a nicer large one in the $150 range. But definitely avoid getting one of those cheap head-mounted magnifiers. They're absolutely terrible for this sort of work. Ask me how I know. If you've been into electronics for a while but still struggle to really grasp it or go off on your own without following a tutorial, listen up. I created a solution just for you called Intuitive Electronics Club. It's a mentorship community on School where I personally help you progress from confused paralysis to skilled execution, teaching you how to think intuitively about electronics instead of memorizing formulas and treating them like a black box. It's not a course. It's a premium mentorship where you get hyper-specific answers to your hyper-specific questions as you work through real electronics projects of your own choice. This is a premium offer for those of you who are serious about leveling up your skills faster and without the usual tail chasing that goes with it. It costs much less than going to college, and you'll have a lot more fun learning by doing rather than working through sterile and, let's be honest, rather boring coursework. Click the link in the description and join now. If the price is too steep for you right now, I get it. I'm currently working on a book called An Intuitive Approach to Understanding Electronics, in which I detail the intuitive mental models which I use to understand electronics, from the fundamentals all the way up to digital logic and beyond. Sign up through the link in the description to receive an email when it launches and receive a free preview of the first section immediately. Remember to hit like if you enjoyed the video, subscribe so you never miss an upload of more videos like this one, and give the video a hype. Lots more to come. See you guys in the next one.